Hello class, glad to have you back, and I hope everybody is okay, and I hope folks are still learning, still engaged in the learning process. I apologize for the technical difficulties we've had throughout the school and especially in my class. Hopefully things will go better this week. I've learned a lot of stuff about technology. Probably more than I wanted to. What was the biggest lesson I've learned over the last couple of weeks? The biggest lesson I've learned is that iPhones do not like PCs, and PCs do not like iPhones. That is the biggest lesson I've learned. I don't have internet where I am in West Virginia. So I'm doing everything through using data on my cell phone. And so the cell phone reception here is critical to the instruction. But I think I have everything resolved, and I'm really looking forward to the rest of the year. So anyways, before we get more involved into rotational motion, I wanted to just do a little demonstration with center of mass again. Hopefully you guys like the center of mass. What I'd like you to do is get an index card or something that's a little more sturdy than paper. I'm going to use paper, but an index card does work well. You want to fold it in half, and you want to make a little heart. And you probably have seen these hearts around my classroom on the wall. And those hearts actually came from center of mass projects, like what we're doing right now. Okay? So you take that, you make a little heart, right? Isn't that cool? So you have your little heart there. Now, since you have index cards, it's going to be more sturdy than what I have. But the whole idea here is to push on the heart, and wherever you push on it and it doesn't rotate, it just moves in a straight line. You want to see where your pencil is pointing, right, and make a line in that direction. It's not going to work very well with paper, but it will work well with your index card. Okay, so I'm going to turn this around, and again, it's rotating. That's not in a straight line. Rotating, not in a straight line. That's well, it may still be rotating a little bit there. Again, this is going to work better with an index card. Let's see, it's still rotating. Okay, it looks like in this direction. And you just keep on turning this around, right? It's still rotating. You want pretty much in a straight line there. So with your index card, this is going to be better. Keep on pushing it. It's rotating. Okay, not rotating there. Okay. So after you've drawn several lines, you're going to see where they all intersect, and most students actually get a point, right, when they're using something a little more sturdy than paper. But the whole idea of this is that you can put your pencil on that point and the object should balance there, right? Yeah, we'll get some balance there. And that proves that that is the center of mass. And that's what you were trying to demonstrate by drawing these lines. See, these lines, or what these lines represent is half the mass of this object is on this side. For this line, half the mass would be over here, half the mass would be over there. And so if you're doing that throughout, you can find the actual point that is the center of mass. Now what you could do after you do that, turn this around and write a note to someone, and write a little happy note to someone, and wishing them well, right? And go ahead and put it in the mail and mail it to them, okay? mail it to a friend or mail it to a relative, or maybe some of the doctors and nurses that are working on the coronavirus pandemic. They would probably appreciate something simple like this, believe it or not. You don't have to worry about contaminating anyone doing this, because what they've shown is that the coronavirus doesn't stay, is not viable after a day, I think, on paper. So even if you have the virus yourself and the virus gets on this, after a day in the mail, it'll be gone, so you don't have to worry about it too much. Okay? So I think that would be really a nice project for you folks to do. All right, so let's move on and talk a little bit about rotational motion. And what I really want you to do is make sure that you are focusing on what's already on Blackboard. Some of you folks are working ahead, and that's fantastic. That's what you need to do. Continue to work ahead and do as many of the Bigler problems as you can. I think if you can do all the Bigler problems and you understand the Edpuzzle videos, I think you're set, pretty much set for rotational motion. But I did want to go over a couple of things just to make sure that you've seen me, at least me, do a problem or a couple problems, okay? So what we want to do is make sure that you understand this table. And I tried to talk about this last week, but I know last week was not good. So if you understand this table and how to use it, you are in great shape. You are in fantastic shape. Okay, this is going to put you in good standing to tackle, I guess, about 50% of rotational motion. Just understanding this table and how to use it. Okay, so let's go through the table quickly. I'm not going to spend a lot of time on it. I don't want these videos to be long anymore. They cost a lot of money for me to upload the videos. So I want to just go through this quickly, all right? So the whole idea of this table is to allow you to convert back and forth between rotational motion and translational motion, or linear motion, which is what we've been studying most of the year, right? And so if you have a hard time understanding some of the components of rotational motion, you can always just convert them back to the linear equivalents, right? And maybe work the problem as a linear problem if you're having a hard time with rotational equations, right? And I do that myself. Sometimes I'm having a really hard time maybe finding an exact equation down here in rotational motion to fit the problem that I'm working. I'm like, okay, I'm going to take all of the variables and just convert them back to their translational equivalent, right? And then find an equation that will allow me to work the problem, right? And then when I get the answer, I can convert back to rotational motion and give the answer with the rotational units. Isn't that great? So this is a great tool to use, all right? And just make sure that you understand all the symbols for rotational motion, all right? They're all new, all right? And what the units are for them, right? And here are just a few equations that you would find associated with those units. So I'm going to just go through it quickly, right? Radians, theta is the revolutions around an object, right? Would be in radians. That's the equivalent to the displacement unit of meters, which is your translational or linear distance or displacement. Okay, for rotational motion, we only have direction of clockwise or counterclockwise. We don't have north, south, east, west, anything like that. However, read the problem carefully because they may provide that information in additional to counterclockwise and clockwise. So make sure you're paying attention to how the actual problem is worded. Here we have omega, right? And that is the translation equivalent would be velocity or speed, right? And that's radians per second. When you are trying to figure out radians over here for displacement, this is when you're going to have to make sure that if you're doing any calculations with your calculator, that you are set on radians. Okay, so just make sure that if there is a problem that calls for radians, that your calculator is set on radians, right? So that you can actually obtain an answer in radians, not degrees. So you have to make sure that your settings on your calculator correspond to that. Acceleration is alpha, right? And that's radians squared per second squared. Excuse me, radians per second squared.